Hey guys, it's time to think about how our backend will work. As for all online games, the most crucial part for our servers is the speed with which it can reply to the clients or push updates to the clients. As we want to have not only local people to play the game, but potentially the whole world, regardless of where they are located, we would need a robust architecture which would be able to handle players' requests as fast as possible from all locations. In the meantime, I don't want to create separate servers for Australia, US, Europe, etc. This would mean that people from faraway countries from each other can't really play together, as some of them would face a huge ping to the servers. I've done something similar before in software development, and we will try to now adjust it a bit and apply it to our game. The idea is to have several global regions deployed across the world, like in US, Australia, Europe, Asia, so players would be redirected to the fastest region based on their location. As we have serverless infrastructure, those regions will cost us nothing if they're not used. On the other hand, all of this will be hidden behind a single domain name, so our players won't even know which server they're connected to. All players' data will be shared across all regions, so it doesn't really matter where you come from, you'll be able to get your game progress and continue. If you have a development background, you might spot an issue right away. Even though we can read quickly from everywhere around the world, we still have issues to write to our database as quick as required. Usually, traditional SQL databases don't support multi-master instances, which means we will have to write to a particular instance which will be deployed to a particular region. So this will be an issue if our master database is deployed, let's say, in Australia, and the players connecting from Europe. Yes, they will be able to read fast the information from the database, but they won't be able to write fast to the database. Well, they won't know this, but they will notice it when they play. And yes, I've had this problem before, and that's why we're not going to use any SQL databases for our game. Instead, we will use NoSQL database as they can offer us exactly what we want, in particular DynamoDB. We can write into a local instance and all data will be replicated in background across all regions. Now let's talk about the backend code. We will have to have our backend to process all game logic for us and reacting to players' interaction. This can be simple move action or hit or other actions like that. Also, backend will have to send back the events to the connected players about other players and objects. This will have to be lightning-fast functions, as we might have a significant number of events from one player. Then multiply this to the number of players, and we will get a high number of events going to our system per second. Just simply running a character on the map will generate around 2 events per second. This will be changing the player's coordinates every 500 milliseconds. If our backend is not fast enough in handling all events, we'll have a huge queue of pending events and player will start seeing lags in the game, delayed movements, and many more nasty things. As we stick with the serverless architecture, we will be using AWS Lambda for hosting our code. The Lambdas will spin up when we need to process an event and will shut down right after it's done. Again, if you're familiar with the AWS Lambdas, you will scream now that Lambdas are not good with the cold start. This is when a Lambda function creates a container which will be handling our request for the first time. Yes, that's right. I've done some research about this, and so far, the possible solution would be to use Go language as the runtime instead of JVM-based languages or even Python or TypeScript. In our particular case, where we get the data from a DynamoDB, Go so far is the fastest in warming up a Lambda function and connect to the database. In comparison, the first run Java can do in around 7 seconds, where Go can do the same in 300 milliseconds, using exactly the same memory allocations. Subsequent runs are also faster in Go than other languages. One issue here is that I don't know Go, and I use it only for a tiny Hello World example. Well, it seems I will have to learn it. Here is a small presentation about our high-level infrastructure design. It's missing a lot of parts, but overall, that's what we've just discussed. And it's easy to imagine it by looking at the slides. So when the player connects from Europe, they will get redirected to the Europe servers without knowing about this. That's it for now. In the next videos, I will start building the AWS resources for this using Terraform. Stick around to check how it goes, and see you next time.